as we get going, let's turn in your books to page 198. We'll look at your homework that you had last night. Page 198, practice 2 through 16 even, and then on page 110, 2 word problems, review numbers 13 and 14. And we're working on multiplying polynomials. And with polynomials, we said if it were a monomial being multiplied, you just distribute. So that if we have a polynomial times another polynomial, we can double distribute. Distribute the first term, and then distribute the second term, and then combine our like terms. Of course, it said it's recommended that we get our polynomials in what kind of order first, class? Descending order. That way, as you do your double distribution, the like terms will fall into nice, neat columns, things like that. So page 198, having that 2 through 16 even out, and then there's 2 word problems, 13 and 14.
It was very messy because I was tired.
Mine's very neat.
Where's the 14 and 16?
I don't know what.
You mean 13 and 14?
Oh no, it's thinking.
No, he has his word problems. He just did 2 through 12 even instead of 2 through 16
it's
even.
kind of messy because I was tired.
Mm-hmm.
So you did it.
And Lana tried to do a shortcut on number 16 and it didn't work.
It did?
No, that's not the answer at all.
Oh.
All right, well, let's take a look at these together. And we will have Adam help us with 14 and 16. He who copies things wrong.
Oh, did she do 2x?
All right, so let's go ahead and take a look at these. Number 2, we had to distribute, or double distribute, I should say, a y negative 2 to a 3y squared positive 3y positive 7. And if we distribute the y, first of all, through the whole polynomial, what do we get initially, Joshua?
3y cubed positive 3y squared positive 7y.
And there we go. And then when we distribute the negative 2 all the way through, what do we get, Lana?
Negative 6y squared, negative 6y, negative 14.
There we go. And then we just add the partial products, add them to get
3y cubed negative 3y squared positive y negative 14.
There we go. How many have the same answer on number 2?
I crossed them out because I thought both of them said squared for some reason.
Okay. All right. Let's take a look at number 4. Having to distribute a 3x negative 2 through the polynomial x squared positive 4x negative 5. And Dylan, walk us through.
Distribute the 3x, please.
Okay.
3x cubed positive 12x squared negative 15x.
All right. Then Joshua.
Negative 2x squared negative 8x positive 10.
And we add our partial products, Lana, to get. There's no way you could botch this one.
3x cubed.
There we go.
Negative 10, or 10x squared, and negative 23x, negative 5, or no, it's 10.
There we go.
I botched that one too.
All right. Okay. Does it make sense what you should have done?
Yeah.
Okay. On the next one, we had an x negative y being distributed to an x squared negative 3xy positive 2y squared. Tell you what, Lon, I'm not trying to pick on your single y, but I do want to make sure you've got this. Ignore what's on your paper. Go ahead and do this problem. Walk us through.
X cubed negative 3x squared y, 2xy squared.
Okay.
X squared, or negative x squared y, positive 3xy squared, negative 2y cubed.
By the way, do you realize now why we drilled and drilled and drilled those distribution exercises?
Yes.
It's got to be automatic. We've got to be able to do it quickly and efficiently because now we're in a double distribution. Good. All right, let's keep going. I'm going to go ahead and put in the 1 right here for us.
X cubed negative 4x squared y, positive 5xy squared, negative 2y cubed. I almost had that one.
And there we go. So you got it now though, right?
Yeah.
All right. Number 7 is just a little bit unusual because, well, you tell me why it's weird. Adam?
Number 7.
Number 7, or number 8, excuse me. What's a little bit weird about number 8? Number 7 is the same way, but that's not what you did for homework.
No, anything has to read back.
Somebody helping?
They're
Oh, right.
The
the
first
X,
one is
the
all
5x,
the way at the end.
the 5x's.
One
No.
squared.
You got a squared? We have a nothing. There's no x to the
Oh.
first power in there. That's outside. Okay, first I thought it was coming from the air vent, that noise. It's coming outside. We're okay. I'm like, something's going to explode right over my head. All right, Scott put it there. We're blaming him. Just because I didn't ship him his donut. I ate his donut. Sorry, Scott. Everybody made A's in the class, so we had donuts. But I had to eat yours.
He's in a
I wasn't upset.
He's in a chainsaw.
All right. All right, so let's go ahead and distribute the x squared all the way through, Adam.
X to the 4th, negative 5x cubed, and positive 8x squared.
Good. Then when we distribute the 1, I'm not going to shift over one place, class, because I didn't lower the exponent by 1. I went from an x squared to an x to the nothing. I dropped my exponent twice. I'm going to double shift. That's the weird thing about this one. Distribute the 1 for us. Don't make this too hard.
X squared,
X squared, negative 5x, positive 8.
All right, I made a gesture toward Dylan for Dylan to do this for us, but that's okay. And I am going to put the positive and the 1 right here. So when we add this up, Dylan, not too hard.
X to the 4th, negative 5x cubed, positive 9x squared, negative 5x, positive 8.
And there we go. How many got that answer? On number 8, you double shifted.
I didn't show the double shifted.
All right. Did you keep things lined up properly at least?
Yeah.
Again, you don't necessarily have to draw the little box shifter thingy, but you know, it's there if you need it. Number 10, what did you get for your answer, Joshua?
8x cubed, positive 22x squared, positive 19x, negative 30.
Good. 8x cubed, positive 22x squared, positive 19x, and negative 30. Number 12 is a little unusual also. Lana, what is it about 12 that's unusual?
There's no 4 and 2.
Right, there's no 4th power of x, and there's no 2nd or squared power of x, is there? So we're going to get some weird gaps that are going to form as we do this. Let's do this one here. We've got the x negative 3, distribute x to the 5th, positive 3x cubed, positive 2x, negative 6. And again, just show you a quick way to accommodate for that, if you will. Let's distribute the x first of all here, Lana.
X to the 6th. 3x to the 4th.
Now, because there's a gap forming there, I'm going to leave a little room before putting my 3x to the 4th. We leave a space where the x to the 5th power could have gone. All right, keep going.
2x squared.
Again, leave a little gap.
Negative 6x.
And no gap needed here because I kept a consistent dissension, right? All right, then we multiply the negative 3 all the way through, Dylan.
Negative 3x to the 5th.
I'm going to put that in the gap.
Negative 9x to the 3rd.
Good. Sign number letter.
And then negative 6x.
And that can go right under the other negative 6x.
Positive 18.
There we go. And then we add these together. Again, there's not a lot that actually has to be added. We just kind of keep our columns here. The x to the 6th, the negative 3x to the 5th, positive 3x to the 4th, negative 9x cubed, positive 2x squared. Cancel?
No.
No, they're both negative.
Negative 12.
Negative 12x, positive 18. Big ghastly looking answer. How many have that answer correct? On number 12.
For the 6x's, for the second part, I think, for some reason I got a positive, so I canceled.
Yeah, careful. Negative 3 times positive 2 is negative
Is it bad
6.
if you for some reason I accidentally put the 4th before the 5th?
It's not necessarily wrong, it's just not best. We want that descending order ideally. Particularly within single variable type problems.
Yeah, and then at the end I think I forgot the 18 altogether.
Okay. Questions, comments on 12?
But I got the rest of it right.
All right, let's take a look at number 14 now. And Adam is going to do the entire problem for us in an effort to dodge homework offense. Adam, number 14, what was my tip that I gave you yesterday in class? when I've got multiple binomials being multiplied. You can only multiply how many at once?
1, right? 2.
You can multiply two things at a time, that's it, right? So which two do you want to multiply?
The 3x and positive 2.
Here's a strategy tip, Adam. This is what I told you in class yesterday. If you have multiple binomials, start at the back. Multiply these two. You can only multiply two things at once. This is a thing, that's a thing. Multiply those two things together. And of course, that's going to be double distribution. So let's multiply the x.
X squared and positive 5x.
Then the negative 4.
Negative 4x, negative 20.
Add the partial products.
X squared, x, positive x, negative 20.
And once we've multiplied those together, now let's double distribute the 3x plus 2. All right, so now do that double distribution.
3x cubed, positive 3x squared, negative 60x, 2x squared, positive 2x, negative 40.
And then we have those partial products.
3x cubed, 5x squared, negative 58x, negative 40.
And suppose, class, there had been a 2x minus 1 right here. Then we will just double distribute the 2x minus 1 all the way through that part and keep going and going. You realize you can multiply many factors as you want. Just keep double distributing. Aren't you glad there wasn't that? So we can say that our answer is done right here. How many have this answer? On number 14.
My brain automatically, when I see 2x's, for some reason I keep putting 2x.
Instead of x squared. X times x, x squared. At least we're discovering this now as opposed to realizing on a quiz or test that we do that. So let's, overcome it now. Question, Dylan.
Oh, no, I was just saying I got it right.
Oh, you got it right. Okay, good. Any questions? Anyone else get it? Okay, so Dylan, good job. Scott, good. All right, and then questions from you guys.
No, I think I just combined some stuff, like...
Let me ask you this. Why would I not just say go in order, do these first two, and then multiply the last one?
Oh.
Thoughts?
Because you want the smaller one in the front.
Yeah, because notice when I multiply two binomials, I get a trinomial. And if I multiply a binomial times trinomial, I come with 4 terms. Every time you multiply, you get an extra term. I don't want the bigger thing in the front, and then that just makes the distribution messier, right? I'd rather have the smallest thing at the beginning. So that's why I work my way from back to front on that multiplication. So for instance, on number 16, we have a 2x plus 1, and it says quantity cubed. Now in Algebra 2, I'm going to teach you how to efficiently cube a trinomial, but it's not Algebra 2 yet. So we're going to have to do this the slow, painful way. What does it mean when we say cubed, Lana?
3 times.
The same thing 3 times. So 2x plus 1 times...
times 2x plus 1 times 2x plus 1.
Right, you didn't do that, did you, Lana? No,
Not
you didn't.
exactly.
You're like, well, if I cube the first term and cube the last term, that'll work, right? Well, we're about to see
Yeah.
not so much. Okay, so Adam's going to help us here. Adam, how should we begin?
Multiply
Multiply what?
2x plus 1 times 2x plus 1.
Which two are you looking at?
The back.
The back two? Okay, good, good. I like that. I mean, you can do it with the front two. It's just annoying. Okay, so let's do it with the back two. All right.
4x squared positive 2x and 2x squared positive 1.
1 times 2x?
Wait. Isn't it positive 2x?
2x. You said 2x squared. And then positive 1. All right. Partial products.
4x squared positive 4x positive 1.
All right. And then we have to multiply this guy still. And I'm going to have Lana take over here.
8x cubed positive 8x squared 2x, and then 4x squared 4x 1.
Good. And of course, don't forget the positives in between them. All right. And then we add the partial products to get what answer we should have had.
8x cubed, positive 12x squared, positive 6x, positive 1.
And you see that your answer,
I
you have the
saved the
first and
middle
last
two.
terms, but you're missing those middle two because you try to take a shortcut that doesn't work. So does that make sense what we should have done?
Is there a short?
There is, but you won't learn it until Algebra 2 because you won't be ready for it yet. Because there's a ton of stuff I have to teach you before you be ready for that. It's some pretty heavy algebra. And then once I've taught that to you, the process becomes really easy. But until you've learned it, it's pretty gnarly. So number 18, what would we have to do if I'd assigned number 18 for homework class?
Number 18,
you
3x negative
3x
4,
negative
3x negative times 3x negative 4 times 3x negative 4 times 3x negative 4.
Wait, it's 4? Oh.
Yeah, doesn't that look fun?
No.
Now there is a shortcut that you're ready for even now, and we're going to get to it in just a minute. But for now, turn back to page 110 in your textbooks, and let's take a look at the word problems that you did for homework. Page 110.
I know it's shortcut.
Page uno, hundredo, teno. Well, okay, anyway. All right, page 110, you had word problems 13 and 14 there in the review section. Go ahead and read word problem 13 for us if you would, Josh. Page 110.
Find 3 consecutive numbers whose sum is 132.
All right, we've done a lot with this by now. How would I represent 3 consecutive numbers, Josh?
X plus 1, X plus 2.
Yeah, first number's x, next number's x plus 1, the next plus 2. So when it says that the sum of these 3 numbers is 132, what's my, what you call equation?
3x plus 3 equals 122.
There we go. And to solve the equation, class, we just need to move the
Negative
Positive
3.
or negative
3 over as a negative 3 to get,
X equals.
well, 3x equals.
Well, 3x equals 129.
And then we need to divide both sides by
3.
3 to get
43.
43. So that means my first number is apparently
43.
then my next number,
44.
and my next number,
45.
and there we go. How many have these 3 numbers?
Wait a minute.
You didn't have?
No, I had x plus 1, x plus 2, x plus 3.
It
I
still
had x
worked out.
equals
42, but your answers were still the same.
Yeah.
Yeah, because it's not wrong. I mean, x plus 3 would be the next consecutive, right?
Yeah.
Well, are these then 3 consecutive numbers? They are. So it works. It's just, gives you slightly more nasty stuff to worry about. I'd rather not, but it's not wrong. Number 14, find 2 consecutive even numbers whose sum is 54. How would I represent 2 consecutive even numbers, Dylan?
2x, 2x plus 2.
Good. Now, technically, you could do 2x plus 2 and 2x plus 4, right? You could do 2x negative 8 and 2x negative 6.
No thanks.
You could. I wouldn't, but you could, right? But I'd rather do 2x and 2x plus 2. And so when it says that their sum is 54, that means our equation, Dylan, is going to be?
4x plus 2 equals 54.
There we go. Where we, of course, move the 2 over class as a?
Negative 2.
Negative 2 to get 4x is equal to 52. And then divide away the 4 to get x equals?
13.
Well, wait a second. Find 2 consecutive even numbers. That's not even, class. Ooh. Oh, neither of my numbers is x. My first number is what, class?
26.
2x. So my first number is,
26.
and the next number?
is 28.
28. There we go. Again,
I was
your
like,
first number is
you
not
scared
x.
me first.
All right, so just a reminder, right? If x isn't one of your unknowns, like for him, 42 wasn't one of his answers. It was his x, but it wasn't one of his answers on the previous problem because none of his unknowns were x. He started with x plus 1. Well, none of our unknowns are x. It starts with 2x. So don't forget to double things up there. Questions on the word problems? Let's revisit number 18 now. And, well, I guess, we got lots of binomials. I mean, technically, you could do this for a whole bunch of stuff, and that'd just be sad. But we should start probably by multiplying the
3x negative 4, 3x negative
well, let's do the last two, 3x negative 4, since they're all 3x negative 4s. But let's multiply the last two together to get what here, Josh?
9x negative
9x
squared.
Squared, there we go.
Negative 12x. Negative 12x. Negative. Wait.
Negative 4 times negative 4, positive 16. And we add our partial products and we get
9x squared negative 24x positive 16.
All right, and then normally I'd say, well, let's multiply this one down. And then we get an answer, then let's multiply this one down, but I got a quicker way, a better way.
Do it just times it by itself.
Yeah, because if I multiply these two together, you know what I'm going to get?
Just
9x.
That. Assuming I didn't screw up here, I'm going to get the same thing, right? Another 9x squared, negative 24x, positive 16. And then guess what I could do to multiply two trinomials? We wouldn't double distribute, triple distribute. I start by multiplying the 9x squared all the way through. 9x squared times 9x squared. 9x squared times negative 24x. Put that calculator away, Scott.
Yes, Scott.
216.
Negative 216x cubed. And then 9x squared times 16.
109.
No.
144x squared. And then we'll shift over and then we'll, oh my, distribute the negative. Well, you get Daddy, you could do it this way, or you could really look forward to that shortcut I'm going to teach you in Algebra 2.
Come on.
I'm going to leave off in the middle of this problem just because it's gnarly, but I do want to do a triple distribution with you, so copy this on your paper, but the numbers aren't going to be nearly as gnarly.
Why do they give us this?
To preview stuff, to show you the thought processes you could use. If you had a calculator or a lot of time, which we don't have a lot of time, nor do we have calculators.
I
so.
do in my locker.
No, we don't use calculators.
Someone stole mine too.
But on the list it said
I gave it to Chris and he
calculator.
never gave it back.
All right, but not for this class.
What?
All right, so let's go and take a look at this. And the first distribution is going to be with the x squared all the way through the other polynomial, right? Don't do anything in here. I'm distributing to the other. What do we get, Adam?
X to the fourth, positive 6x squared, positive 5x. Wait, oh,
You're right about the x to the fourth.
wait, oh, negative 2x cubed. I don't know why.
And part of I discipline is ignoring the extra, right? And that's what we're going to have to do there. And then continue.
5x squared.
There we go. All right, now it's all about the negative 3x. Again, I discipline only focus on the negative 3x as you distribute into the other polynomial, Dylan.
Negative 3x squared
Cubed.
cubed. Positive 6x squared. Negative 15x.
All right, and then Joshua, it's time for the negative 4 all the way through.
Negative 4x squared, positive 6x.
Careful, negative times negative is
Positive 8x.
positive, but 4 times 2 is 8x, all right?
Negative 20.
By the way, notice, because we've got descending order in both, we shift over again, right? And I think I showed this the other day when you have multiple terms, you just keep adding zeros in a regular multiplication problem. Well, here we just keep shifting over. And now Lana gets the fun part of combining like terms.
Oh, come on.
It's your turn, Lana, don't whine. Can't divide whiners, remember?
Divide by
X to the fourth. Negative 5x cubed. 7, positive 7x squared. Negative 7x, and then negative 20.
And there is our answer. Questions on this? So again, you get the idea. It doesn't, now again, as long as you're not really, really bad or something, you're not going to get like quintuple distribution where there's 5 terms or something, some nonsense like that. But you get the idea. Using this process, you literally could multiply any 2 polynomials together no matter how big they are. The bigger they are, the longer it takes, the more annoying it is, but you could do it. Do you understand? Right? And that's kind of the point of showing this one, is just the fact that this process, you just keep doing it over and over, it would take care of any size polynomials you want to multiply. Now, sometimes you may see, again, particularly if you really tick me off or something, you could see something like this, where maybe we have literal exponents, so be nice to the math teacher. Well, you do what you normally do, right? You distribute the 3x to the n, and we do sign, number, letter, right? Class, sign,
Positive.
number.
3.
And when we multiply like bases, we
Add
add the exponents. So that's going to be x to the n plus 2n. What is n plus 2n? 3n. n plus 2n
Oh,
is
yeah.
3n. And then we're going to multiply here sign,
negative
number,
9.
letter.
N squared.
No.
2n.
2n. n plus n is 2n. So a negative 9x to the 2n. And then sign,
Negative
number,
15
letter.
X
to the n. Oh.
All right, and then we're going to shift, and we're going to now take the 4 and distribute that all the way through, Adam.
4x to the 2n, negative 12x to the n, and negative 20.
And then we just add the columns together, Dylan.
Positive 3x to 3n. Negative 5x to the 2n. Negative 27x to the n. Negative 20.
So even literal exponents, as long as you remember what you're supposed to do when you multiply like bases, add the exponents, and you remember how to add it, it's a little obnoxious, but again, it's doable. Again, the point of showing a couple weird ones here at the end is, yeah, you literally could, it doesn't matter how ugly or awful they are, you could do it. Again, it might take a long time, probably don't want to do it, but you could do it. And that's, I guess, trying to give you the confidence that the skill that you have takes care of any situation. It's the great thing about math, right? Because nothing changes, unlike English, right? Question.
Can you have an exponent have an exponent?
Absolutely, yeah. So for instance, if you, well, we're not ready for that. Well, yeah, I taught you this, that if you raise a power to a power, you multiply the exponents. So this would be like a to the 15th. So if I had a to the x, and I multiplied that by the x, well, I have to multiply or raise it to the x power, multiply the exponents, that's a to the x squared.
Oh my!
So yeah, you can have an exponent on an exponent, absolutely.
So it can just go on forever.
You could, I mean, you know.
Oh,
Yeah, it'd be, you know, I suppose. Anyway, we move on though. Next section, your notes. That kind of wraps up multiplication for us for now. Okay, and that is because you, at this point, literally could multiply anything. So that brings us to our next topic in our notes, which is dividing monomials.
Oh,
We've talked about adding and subtracting, which is really adding and adding the inverse. We talked about multiplying. That brings us to dividing monomials. Dividing monomials.
Oh, yeah.
3 steps. Sign, number, letter. Write them down. Sign, number, letter. We know this with division in general. If you divide the same signs, positive by positive or negative by negative, you get a positive. So for signs, if the signs are the same, you get a positive. But if the signs are different, positive divided by negative or negative divided by positive, if the signs are different, you get a negative. Pretty easy, right? Now with multiplication, we had that multiple factor thing, remember? Where we had like multiple factors all being multiplied by each other, and we had, some of them were positive, some were negative. We had the even odd rule, remember that? You're not going to have to worry about that with division because you have one thing divided by one thing. By the way, how do we normally write division? Solana puts her foot down.
A fraction?
Fraction bar, right? So most of our division problems are going to be shown with a fraction bar. So you're going to see the signs one above the other, perhaps. Number 2, number. Divide.
So funny.
Unless you can't. For instance, can I divide 3 by 12? No. Can I divide 30 by 12?
Yes.
No.
No.
Not evenly. So I want you to write this down. Divide, but if you can't. Right, with multiplication, remember I said on the number, just multiply it. Because you can always multiply. You can't always divide. So if you can't, reduce. Because it's going to be written in the fractional form, if you can't actually divide the numbers, just reduce them. So if I had, you said a 3/12, I would call that 1/4. If I have 30 twelfths, I could call that
3.
10
1/4.
4.
10 fourths, or I could further reduce to
9/3 or
about
1/3.
5 halves. Take a 6 out of both numbers.
Oh.
Oh,
Right?
I was thinking 36.
But I could reduce the fraction down, right? So if you can't divide, class,
You reduce.
Reduce. Okay, that's as far as the number goes. And then finally we come to the letters. Letters. And write this down, put a star next to it. As I run out of room. To divide like bases. Well, what do you think we would do? If we multiply like bases, we said we add the exponents. So since division is the opposite to divide like bases, subtract the exponents. To divide like bases, subtract the exponents. Say that with me, class. To divide like bases, subtract the exponents. Again, to divide like bases, subtract the exponents. So if I've got a problem that's division, and I've got like bases, what do we do with the exponents, class? Subtract them. If I want to multiply like bases, add the exponents. If I want to divide like bases, subtract the exponents. If I want to raise a power to a power, multiply the exponents. But if I want to divide like bases, subtract the exponents. But if I want to divide like bases, then we would subtract the exponents. But if I want to multiply like bases, we would add the exponents. So I just got to keep all those rules straight here, okay? For instance, write this in your notes. If I have to say an m to the 10th divided by an m squared. Well, think about what this literally means. It means I've got 10 m's in the top. But instead of writing m, however many that is, over m, and then I could, though, cancel an m and an m in the bottom with 2 of the 10 m's in the top, right? That would leave me with how many m's? 8. Hence, m to the 8th. Or the easier way to think of it is just subtract. 10 minus 2 is 8. Make sense?
Yes.
Write this one down. If I had a to the 7th divided by a cubed, what would I get, class?
A to the 4th.
A to the 4th. Because these 3 a's are subtracted away from these 7 a's to leave me with 4 a's, right? Technically, class, that's an m to the 8th over 1. Because the 8 m's are left in the top. Technically, this is an a to the 4th over 1. I just don't like to write the over 1. But what if I had, write this one down, a b squared over b to the 4th? Well, here I have 2 b's in the top and 4 b's in the bottom, right? I'm still going to subtract the exponents. What's 4 minus 2?
Negative.
No, what's 4 minus 2?
2.
2. But those 2 b's that are left in the denominator. Does that make sense? These 2 and these 4, I cancel 2 from each of them. And I'm left with 2 b's in the bottom and no b's left in the top. But what is still in the top?
B.
A 1. No b's.
Oh.
There's a 1 left in the top. Just as there's a 1 left in the denominator. Do I have to write a denominator of 1, class?
No.
But I do have to write a numerator of 1. So you might want to jot this down. If the bigger power is in the denominator, when you subtract, leave the answer in the denominator, but leave a 1 in the numerator. Does that make sense?
Can you repeat that?
Something along those lines. It wasn't even supposed to be necessarily word for word, but if the bigger power is in the bottom, leave the answer in the bottom, and a 1 in the numerator. But what if we had something like this? X to the 5th over x to the 5th. Well, now all 5x's cancel with all 5x's. What's left in the top, class? 1. What's left in the bottom?
1.
1. In other words, my answer is just
1.
1. Another way you could think of it, though, remember we said we're going to subtract the exponents, right? What would you get if you subtracted 5 minus 5?
0.
0. You could also say your answer is x to the 0 power. Write this down in your notes. Anything to the 0 power equals 1. Put a star next to that. Anything to the 0 power equals 1. I believe you learned that last year in pre-algebra, right?
Yeah.
And again, this is just kind of a re-emphasization of that. Saying it again. Okay, so anything to the 0 power equals 1. And then again, you're dividing something by itself. You divide anything by itself, you get 1, right? 32,600 divided by 32,600 equals 1. Anytime you divide something by itself, it's 1, including x to the 5th divided by x to the 5th. 1. Or x to the 0 power, but it's easier to write
1.
1. All right? Write this in your notes now. Let's go through the whole process with the sign, number, letter thing. Okay, so I was just showing you the letters, how it works to subtract the exponents when you divide like bases. Write this down. Negative 30 x squared y cubed divided by negative 10 xy. Sign, number, letter. What's my sign going to be, class?
Positive.
Positive, because the signs are the same. What's the number going to be?
3.
3, because 30 divided by 10 is 3. Then when I subtract the exponents, remember the x and y have what powers right now here?
1.
Ones. So when I subtract the exponents of the x, I end up with x to the first. When I subtract the exponents of the y, I get
Y to the
Y
second.
to
y to the second, or y squared. Make sense? Sign, number, letter. Write this down. 25 a cubed bc over negative 5 ac. Sign, negative. Number, 5. A
Square.
squared, because we're subtracting 1 from the 3. There is nothing else to divide the b by, so that means
B.
just keep the b, right? It has no friends, just keep it, just like a multiplication. What's going to happen to the c's?
They cancel.
They're going to cancel to leave me with a 1, but do I really need to write that 1?
Not really.
This time, no, because there's other stuff, right? And stuff times 1 equals the same stuff you started with. So if there's more than just the letters, even though technically it gives me a 1, I'm just going to say to cancel, let's not worry about it anymore. Make sense?
Why would they cancel again?
Because when we subtract the exponents, we get c to the 0, right?
third one.
And c to the 0 equals 1, and 1 times anything is itself, so there's no point in writing it,
Yeah.
right? For instance, Joshua, you're 14? Yeah. So if someone's like, Joshua, how old are you? I'm 14 times 1. Just say 14, right? What's our answer? Negative 5a squared b times 1. Just say negative 5a squared b. Does that make sense now? So yeah, if the letters match, just cancel them away. Write this one down. 10 x to the 5th y squared, that's a 5, it just doesn't look very good, over 15 x cubed y cubed. Sign.
Whoa.
Positive.
Positive, which I could leave understood, correct. Number. Ooh, is it going to divide, class?
No.
If you
Two
cannot divide,
Reduce.
reduce. 10/15 could reduce to
2/3.
2/3 when you divide a 5 out of both numbers, right? Reducing the fraction. What do I get for my x's?
Squared.
X squared, is that going to be in the top or bottom?
Top.
It's going to be in the top. So I'm going to extend the fraction bar a little. I'm going to put the x squared in the top. When I divide the y's, what do I get? Y to the first, but where does that y to the first need to be?
The bottom.
In the bottom, because these two y's cancel with 2 of the 3 y's to leave me with 1 in the denominator. Does that make sense now? Okay, let's do one more together, then I'll have you work some on your own. Negative 4ab squared over a to the 4th b squared. What's my sign going to be here, class? Negative. What's my number? 4. Because there's an understood 1 here. 4 divided by 1 is 4. What about my a's?
A cubed
3.
at the
A
bottom.
cubed in the bottom because the bigger power was there in the bottom. So we're going to leave it in the bottom. What about my b's?
They can.
They cancel. We're done.
So it's just negative 4.
Negative 4 over a cubed.
Yeah.
Easy enough?
Yes.
Questions on this?
No.
Turn your textbooks to page 202. Page 202. I want you to do numbers 5 through 13, the odd. Page 202. Do 5 through 13, the odd numbered problems.
Just 5.
Thinking through sign, number, letter. Good, good, but think quietly. Looking for something, in case you probably figured that out already.
Find that something.
I didn't know. It was sad. Who's finished? Dylan's finished. Just 5 problems.
I was copying them all the questions and then the answer.
Oh no, ain't nobody got time for that. You can do these in your head. These are easy.
I did that.
For instance, on number 5, what do we get, Dylan?
Number 5y squared.
5y squared, we do that in our head, sign, number, letter. How about number 7? Adam?
2x to the 5th.
2x to the 5th, we do that in our head, right? Number 9, Lana?
Negative 2xy squared.
Negative 2xy squared, we do it in our head. Number 11, Joshua?
2x over 3.
2x over 3. I will also take 2/3 x, but I prefer 2x over 3 anyway, so I like that. How about number 13, Dylan?
3xy squared.
Ooh. Adam?
6xy squared over 7.
6xy squared over 7. I think you misread it and you thought it was a 12 over a 4, which would have been 3, but it's 12 divided by 14, which is 6/7 when you reduce it. So 6xy squared over 7. All right, we got it now? Kind of got the feel of it? Okay, let's do some more. Let's go on to 15 to 21, the odd.
This time I'm not copying.
Okay, don't copy them down if you can help it. 15 to 21, the odd now. So I saw a bad joke the other day. Said I had some odd jobs around the house I needed done, so I made a list of 10 odd jobs and hired a guy to take care of them. When I came back, he'd only done jobs 1, 3, 5, 7, and 9.
What?
Don't worry about it, Dylan. Go back to sleep. I appreciate your diligence, Dylan. It's like I don't have time to listen to jokes. I got work to do. That's good. That's good. I should admire that. Getting an email from Scott's mom. Scott says, please stop telling jokes. They make him cry. You think it would be funny?
Probably.
If I can't have my own donut, just don't tell jokes either. It was a very good donut, by the way.
Poor
Still slightly
Scott.
warm.
Send him a bill.
Glaze.
Send him some money in the mail to buy a
They're so
donut.
bad. Because you know you want something and they make it like that much worse. It's like,
It's only what, like?
It's only 2
Yeah,
bites.
I don't really know. It's only like, what, 10 close? No, it's less than
All right, let's see how we did on these other odd problems. Number 15, when you did sign, number, letter, what did you get, Lana? Number 15.
8a cubed over b.
Oh.
How about 8a cubed over b cubed?
Oh, I forgot.
Oh.
Right, we got a b in the top and a b to the 4th in the bottom, so we're going to cancel the b
Yeah,
with
that's what I
one of the
did.
4 b's to still leave us 3 b's in the bottom. So 8a cubed over b cubed. Number 17, Adam.
7y over x.
Just one small little detail. There's a negative floating out in front, so let's not lose that
I
negative.
put that, but I didn't.
Yeah, negative 7y over x. If you're not careful, it can blend in with your fraction bars, so you just be careful. Negative 7y over x. Number 19, Dylan.
I got 6x squared over 5y squared.
Good, 6x squared over 5y squared. Number 21, what did you get for your answer, Josh?
positive x, t to the 5th, y to the 6th.
Lana?
X t to the 5th over y to the 6th.
Good, and there's only one small edit I would make. Scott got it. T to the 5th x over y to the 6th,
Oh,
alphabetical
yeah.
order. But I wouldn't hold that against you if this were on a quiz or test because they printed it out of alphabetical order. So if they screwed up, I'm not going to hold it against you if you also screw up. But technically, the t to the 5th should go before the x and then over the y to the 6th. But anyway, questions on those odd problems? All right, we will continue with more of that in our next lesson. For short homework assignment for you this evening so we can stay on track, page 202 on the review, do 1 through 10 and 15. Page 202 in the review section, do 1 through 10 and 15. Should take you about 5 minutes. So not a long homework assignment, but do want to keep on pace with some previously recorded videos. So page 202, review 1 through 10. Hey, Clacky, hush. Page 202, review 1 through 10 and 15. And we'll pick up this division of monomials in our next lesson. Have a wonderful rest of your day.
Bye, Scott.